I'm Dave Shoup. Been here at Hunter for 24 years. We have ACC2 conventional and ACC2 decoder. Presentation is mainly on decoder because they have essentially the same features. But I'll talk about conventional as I move through this. Okay, so this here is ACC2. It has an uber cool color display. It's got a dial, but no dial positions. It spins and spins and spins. And then you push in on it like a mouse to click and select things. There's down the side are ATM buttons that we call soft keys, but they do different shortcuts in every single screen, including the home page. They're always labeled on the screen. Over here we have a back button and a home button. So if you can't remember how the hell you got somewhere, just use these to go back up a level and figure it out. It takes a couple of minutes to get used to, and then it's really cool. This is compatible with ICD decoders, not easy decoders. In the conventional version, it has 6 station output modules and goes up to a max of 54 stations. In the 2-wire version, it goes to 225. And that drives a lot of our other ridiculous specifications that I'll cover quickly. The interface, high-res color display, multiple languages. So you can switch the product to over a dozen languages. If your customer is more comfortable with Espanol or Deutsch, you can switch the entire interface, all those menus, everything, change to their preferred language. You can actually change this to Chinese. If you do, it's real hard to get back to English. So don't do that. When he's running Irrigation live, it shows all the events, everything that's running right here on the screen. A lot of people don't know it, but you can use this to click on any one of those events and stop just that one, and the rest keep running. Units of measure, you can switch it to a metric, which of course you would do in Europe, and gallons for good old USA, the last people that use it, and that's that. This is one of the coolest features. This is the control panel that we call a Facepack. It's held in by a magnet, and you can pop it out of there with your hand, feed it right through, turn it around, and install it backwards. When you install it backwards, first of all, it's extremely convenient. It knows it's been switched around. It goes right to our diagnostic screen. But you can get back to all the menus and all the programming and all the other diagnostics in this position. And do it while you're looking at your LEDs, your modules, pulling on your wires, and all that kind of stuff. You can leave it this way. You can leave it this way all the time. It will run automatic programs in either position. So if the kids get in here, it's boring. There's nothing to mess with. But when a qualified user comes out or a technician, it opens up the whole thing like a book. That's a fun feature. This is a heavy controller. The metal version is 29.2 pounds, which is about 13 kilograms. It's a separate wall mounting plate. You just put the plate up, mount that, and then you hang the controller on these hooks. Then you open the door, zip in one more screw just to hold it in place so it doesn't get bumped up, and it's installed. ACC2 has 32 automatic programs, which is plumb ridiculous, but we got 225 stations. We have 10 start times per program, 12-hour max run times, but better yet, any stations can run in any order. The order in which you put them in this display is the order in which they actually run. If for some reason in a program I wanted to start in the back of the room and run each of you one at a time toward the front of the room, just build your program that way, no problem. It also has 1-second resolution of run times. The conventional model will actually run 1-second run times, which is good for nurseries, propagation beds, things like that. The decoder version, the minimum runtime is 15 seconds because we have two-way communications and we have to allow for retry attempts. But after 15, you can go to 16, 17, adjust in seconds as well as minutes. It has programmable non-water windows for each of the programs. If you have a complex like here at Hunter, and you don't want anybody to water accidentally, like during the daytime when customers are walking around, you can set up a non-water window, say from 7 in the morning till 9 o'clock, where it will never allow automatic irrigation. It will always allow manual irrigation. If you've got a technician out there during the day, they can always start stuff for test purposes and things like that. Calendar days off, so I could sit here and say don't water on 4th of July. And this little screen, the program summary, I don't show this as much anymore. This will show how all your programs are going to stack up in time. The blue are your start times and how long the program runs. The red are the no water windows. Then there's blocks. A block is an electronic group of stations. They can be anywhere in the system. And they're stations that come on together, run for the same runtime, and then shut off. You can put these blocks into programs just like individual stations, right? And a block can be from 2 to 8 stations. You can have up to 64 blocks in a controller. And there's several reasons why you might want to do that. The bigger the system, though, when you got 200 some stations, the better blocks are, because they consolidate a whole bunch of things you have to program to a smaller number of things. And especially nowadays, we see a lot more drip and low volume irrigation. You can take 4 of low flow stations, put them into a group, and safely run all of them together. You can use the block to disperse flow over different pipes. And you can also use it for fertigation. If they have fertilizer injectors, you can use a station output to operate the fertilizer injector and then put that same station into all the blocks that need fertigation. So every time the station comes on, the injector comes on, and the ones that don't need it would just come on by themselves. Lots of different magic tricks you can do. Now you can have up to 8 stations. You pick the stations. They don't have to be in any order. They don't have to be near each other in the real world. Whatever you want to group them as. Maybe it's for plant types, anything. The transformer in the ACC2 is probably the best transformer in the irrigation industry. You will almost never have to replace one, but if you had a direct lightning hit on the clock, you may. It's a lot easier to do than it used to be. And it has enough power to run 14 Hunter solenoids simultaneously. 14? Yep. And we say Hunter solenoids because our solenoids are lower draw than a lot of competitors, but it'll run a whole lot of competitor solenoids too. In the 2-wire version, it'll actually run 20 solenoids over decoder simultaneously. Decoders are very electrically efficient. And if you have 2 modules installed like I do, you can run 30 solenoids simultaneously. If you got enough water, we got enough electricity, is the takeaway there. This transformer is intelligent. It will protect itself from overloads. If they try to turn on too many things, 15 conventional solenoids, it'll shut off that last station. It won't let that run because it knows it's right at the edge of blowing up, so it will protect itself. It also has another incredible Hunter innovation, for anyone who can see it, an on-off switch. So you don't have to go all the way back to the breaker or pull the fuse. It does have a fuse. It's a regular 250 volt fast blow stereo type of fuse. Those are harder to find than they used to be because there's no more Radio Shack. So there's 2 spare fuses right here under the sticker that says spare fuse. And that's kind of handy. Transformer is either or. It can be 120 volt for United States, 230 volt for use on a pump station or for our international customers. There's 3 wires hanging down there. Brown is 230, black is 120, and the blue wire is a neutral. So you use blue plus the voltage of your choice. If you hook it up wrong, it'll run real fast for a second. Then you will take a spare fuse. Easy to replace, and that's true about everything in this controller. The whole thing is designed with number 2 Phillips head screws, and all the screws are captured. So you never have to unscrew and the screw rolls down in the grass and you spend a half hour looking for it. They just loosen up and then you pull the piece out, do whatever you're gonna do, stick it back in and tighten it back down. The serviceman's dream. These are the output modules. No tools required, 75 stations per module. The base product comes with 1 module installed. It's a 75 station controller. Add another one, 150 stations. Add a 3rd one, 225 stations. That's how it works. There's up to 3 2-wire paths per module to go whichever way you gotta go. And a little trick we learned from our friends in Florida, where they have a lot of lightning, automotive fuses are now on the output side of the 2-wire. It's a 20 amp standard automotive fuse. This is your last ditch attempt to stop the lightning if it gets past all your earth ground. And there's 2 spare fuses and a fuse puller tool If you run out of all the fuses, you can, in an emergency, you can take one out of your truck. The spec is 20 amp. Wiring options. So I said each one of these modules got 3 2-wire paths to the field, but you're not stuck with that. If you have more than one module installed, but you want to move some of his stations over to the first module, just think of it, each one of them unlocks another 75 stations. But you can use this here screen to take some of the stations or all of the stations from module 2 or 3 and move them over to module 1. So if the design was a whole bunch of decoders on a single pair of wires, you could literally have all 225 on a single pair of wires off the first module. Pump master valves and flow sensors can also be done on the 2-wire path. Lots of decoder diagnostics and tools. So if the decoder's modules are installed, you see an extra menu that conventional guys don't see, which is the decoder menu. And it lets you program the decoder, do some other stuff. One that I like is the decoder inventory. That will go out, and it takes a while. It's going to go down all the 2-wire paths and look for who's out there. And it will build you a list of all the decoders that answer that it finds. And another cool thing about it is your communication percentage. So it's a 2-way system. Every time we send a message to a decoder, we expect to answer back. This is a test system, right? It's always 100% in testing. In the real world, those numbers are going to be lower. That's the number of times, it reflects the number of times I tried to talk to a decoder and I didn't get an answer. And it's okay to a point. But if you see this number getting down around 50, 60%, it's an indication that something is wrong with your wire path, that you got crappy connectors, or you got a nick in the wire with a short to earth ground. It's working, but it's not getting all the messages. So it's kind of a hint for a preventative maintenance. If one of those is at 50% and the rest look pretty good, I'm going to go to that valve box and see what's going on with that one. Built-in wire tracking mode. So in the old days, we had to take a separate 24-volt transformer, hook it up to the 2-wire path just to put 60 or 50 hertz on it, so you could go track for shorts with a clamp meter, an AC clamp meter. Now we built that feature into the controller. So it'll put the 50 or 60 hertz on the 2-wire path for you, and then you're ready to go use a clamp meter to find a short in the earth. And another good one is the station finder. I don't know if this happens in your world, but it is possible to lose a valve box. Mud washes over the top, the weeds grow on it, looks just like the rest of the lawn. What this will do is chatter the solenoid for up to 30 minutes. And what we found in testing, if you chatter that solenoid a lot longer, you will smoke the solenoid. It can burn it up. So this will only operate for 30 minutes, but then you can go out and listen for where that thing's chattering and find your lost valve box. This controller is all about flow. This controller can handle up to 6 flow sensors, and wherever you have a flow sensor, you want a master valve, so it can handle up to 6 pump master valve outputs. 3 of them are always built in, all of them. There's 3 flow inputs and 3 PMV outputs. You can expand up to 6 several different ways. One of them is this special module that only goes in that special slot, and that gives you 3 more inputs for the flow sensors. But most of the time when that comes up, it's in a 2-wire system. For that, we use a sensor decoder, ICD Sen, and that can be anywhere out in the 2-wire path. Just connect your flow meter over to the sensor decoder, and it will read upstream on the 2-wire path. Same with your master valves. There's 3 master valve outputs, but you can designate any station or any decoder as a master valve output. This one, we have people from West Coast, okay? We get system designs over here that spec normally open master valves. Most master valves are normally closed, but West Coast designers seem to like normally open master valves. This one has true full support for normally open master valves, and it works with a very broad range of flow meters. This will work with almost all of them. It works with ours. It works with Badger, Data Industrial, kind of the old industry standard, click, 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 K-factor, velocity based. It works with, you've seen the ultrasonic meters like a flow mech, and it will work with what we call scaled pulse. And that's like the HydroWise sensors. These don't have a K-factor, Instead, you calibrate them. You say 1 click equals 1 gallon, or 1 click equals 0.1 gallons. So you can set either one up in this controller. Your NetFMs, the Burmod and the ROD meters, they read this way, so we can work with them. If you're interested in station level flow monitoring, we prefer the K factor type because we get way faster clicks. We get more clicks per gallon, or per liter, sorry. And so it lets us do diagnostics much more accurately and much faster. These scaled pulse meters, you get 1 click per gallon, and if it's low flow, you get very little feedback from the field. So they work fine for high flow shutdowns, but for station level diagnostics, not as good. So once you got flow sensors, we can do a couple of different things with them. One is flow management, which technically does not require a flow sensor, but it's a lot better with it, and flow monitoring. Flow management gives it the ability, permission, to turn on any stations in any order to get to a flow target. Now, why would you do that? It's kind of like a golf course system. You're trying to optimize the flow. If you know your pipe size, you know the target velocity. So this guy's got a 2-inch main line, and you want your flow to be about 5 feet per second because all your hardware is going to last longer, and that's how the IA teaches it. So 55 gallons a minute, which is a bunch of liters, in a 50 millimeter pipe is about 1.5 meters per second. No problem, that's where you want to be. So you enter that in here as your flow target. Here, you can literally set all of your start times to the same time, set all your programs to overlap. It gives him every station that's legal to run today. He'll start turning them on until he gets to your target. When one of those stations times out, he'll look for another station that he could fit in to keep it up near the target. And what you're doing is letting the controller figure out how to get the most irrigation done in the shortest water window at safe velocities. You can put other controls and priorities, get as fancy as you want, but that's the concept. He knows the flow for every single station. This station is 15.3 gallons a minute, which is a bunch of liters. The best way to get this is to let the machine learn it. Hook up the flow sensor, tell the controller to learn it. He'll start everything and store the flow for you. But if you can't do that, you can enter this data by hand. It won't be as accurate, so your choice. And that, in turn, will look like this. So this guy has a point connection. He basically has 3 of what we'll call flow zones, right? He's got 3 kind of sub-mainline pipes. This might be going off to different ball fields, and the pipes may be different diameters. In the setup process, you tell every station what flow zone he's a part of, and then he knows which guys are on which pipe. You can set a different flow target for every one of these flow zones. Depending on the diameter, this one up here is 50 gallons a minute, this one is 65, this one here is 80. And of course, you would see all this in liters. And that's how he knows what he can run on a given flow zone. And he'll be doing this simultaneously across all your flows. Then, that's when your flow monitoring kicks in. The flow monitor is looking at the flow meter that's on the piping system. And he knows the stations that are running, he knows what they should be. Now he's looking at the real world. Maybe he's doing the flow management thing, or you're just running a ton of stuff at once. He adds up what ought to be happening based on the learned flow and compares it to what's really happening in the field. So this guy spent the extra $1, got the flow sensors and the master valve. Irrigation starts running. These 3 stations, for example, come on. He adds up the learned flow. He looks at what's coming in from that flow center. And if he sees a high flow, and you control what that is, you set it a certain percentage over normal, and it has to last a certain amount of time. I recommend most systems start at 120%. In other words, 20% over normal, because irrigation systems fluctuate a lot. If he sees high flow, the first thing he does is shut off all the stations that we're running for a minute. And he waits to see if the flow drops up here. Because if you shut off all those zones and the flow doesn't drop, what does that tell you? Mainline break. So that's bad. What he'll do is shut down the master valve right then and send an SMS text to your phone. But if it does drop, we say, okay, the problem is downstream. It's in the valve or the combination of valves that's running. So what I'll do now is sample each of the valves that was running at the time the alarm occurred and see if it's working or not, if it's working to spec or not. The ones that are high flow, he will kill them. And then he will resume irrigation with the ones that pass the test. And you will get alarm messages in the logs into your phone about the stations that are broke. And it doesn't need the internet for anything. It's all in that box right there. The only thing that would require a connection to the cloud is to get that text sent to your phone. There's another more of a spec or design level that you can do. You got 6 flow sensors to play with. There's a thing called MainSafe, which is sort of cool. This is when you have a gigantical water source and a huge mainline pipe that might be going a long way before it splits out into your flow zone. MainSafe is a separate level of flow protection that is just for the giant water source. If this pipe breaks, it might be a 400 millimeter pipe, which is a whole bunch of inches. That's going to cause a disaster really quick. So what you do is you just put the number. I don't ever want to see more than X amount of flow running through this pipe. If he sees that exceeded, it will shut down right away, send that text to your phone if you're connected, and that's the end of that. He's not going to bother doing all this station level stuff. It's too late for that. So that's like an extra emergency brake, so we don't dig up turf and highways and stuff. Some more advanced features: user management, password protection. There's 2 levels of access. An admin can do anything on the controller. A crew member can only turn stuff on and off, but they can't change the programming, right? Each user gets his own PIN number. Whenever they log in here, it's tracked in the controller log. You can go in there and see who logged in. This has another cool feature called Conditional Response. Now this will blow your mind. Most controllers, not just ours, but almost everybody's, they have a sensor input, and all it does is kill stuff. It turns off the irrigation, because usually it's for a rain switch, sometimes soil moisture. I don't want water anymore. The sensor clicks, it turns everybody off. We thought it would be cool if you could use that sensor input to do stuff, to start things, and to switch things. You can have 35 conditional response statements. You can use a sensor input to start a program or a station. Maybe you've got real critical irrigation, you have a soil moisture sensor out there, and it clicks when it's super dry. It could automatically start irrigation right then and there, based on that input. You can also use it to switch your pump master valve. In other words, to switch your water sources, as this dramatic illustration proved. This guy's got 1 flow zone, just to keep it simple, with 2 water sources, right? And one of the sources is a tank, and it might be rainwater harvesting, might be reclaimed. It's free water or cheap water. And when that tank is full, we want to use that. So you put a float switch in there, just simple contact closures, high and low. And when it's in the high position, he says, okay, my statements tell me, close this master valve, open this master valve. So now I'm drawing my free water out of the tank. When all of a sudden, in the middle of the night, the tank runs dry. Float switch hits bottom, switch changes position, and the response statements say, close this master valve and open this one. Another thing you can do, coaches. I used to call this feature coach step. The water comes on and he wants to keep practice going, or the water is not on and he wants to do the infield for dust control and traction and stuff. Go to like Granger Industrial Supply and you get you 2 big push buttons like they have on factory equipment, punch presses and stuff, and you set up conditional response statements. In fact, there's another part of this trick. What you can do when automatic irrigation is going to start, make station 1 a red light. Use like a pump start relay booster or something like that. That red light has maybe a 3-minute runtime. When the red light comes on, it means the water is going to start. So send your fastest kid over there, hit this red button, and it will stop the water. Otherwise, it'd just time out and then the sprinklers start, right? But the green button, they hang down underneath the controller. The green button is for when you want a certain kind of water, the infield or something, whatever the coaches want to do. and do a conditional response statement and say, push the green button when you want that kind of water. See them used for watering in dog parks, where we're doing the irrigation anyhow. They want to make a spigot or something available for the dogs. Set up a push button, use conditional response. So those are just some ideas. All that stuff is in there. None of them need or use the internet. On the back of the Facepack, you've got SD card reader. You can use this for a lot of things. The number one thing is to update the Facepack. So the Facepack runs on software, which we call firmware. Updating it to the latest version is always a good idea. There's often bug fixes and new features. They're free on our website on the product page. Load that onto SD card, bring it out in the field, stick it in there, you get the latest version. Centralus software also now has the ability to send the updates over the air. How many of you know about easy retrieve backups? Almost every Hunter controller, and especially this one, has a backup for your perfect program. That way, if you have to replace a Facepack, you can, on most of the controllers, there's secret buttons that you can hit to restore that backup you made. It'll save you a lot of time trying to remember how it was programmed. You can also, in a standalone controller, save all the logs. The logs in this controller are so cool. They tell you everything that's going on and has gone on. Oh, another thing, the people that are smart that use Easy Retrieve, which is all of you now, often ask, can I save more than one backup? Like I got a spring program and a summer program. The brain itself only remembers one backup, but you can save all you want to this SD card. So then you could go in and call up the spring program or the summer program or the overseeding program and just, that's what worked last year, I want to do it again this year. There are 3 different communication modules: Wi-Fi, LAN or Ethernet, and cell. The vast majority of ACC customers use cell communications. It's 4G, and it uses the newer technologies for Internet of Things called Cat-M1 or NB-IoT. Those are connected to the Centralus software. When you set the controller up in our Centralus software, one of the steps, you say, I'm going to do cell, and it says, okay, do you want to use the Hunter SIM card or do you want to use your own? If you use the Hunter one, you go into a third-party outfit that we work with, which is excellent, called Zipit. It's going to be $10 a month. Our system will work to AT&T wireless. We use the little tiny SIM card, the nano card. Most of them now, they're like big and you can break them off until you get to the size you need. And we use the smallest size, the nano. For the professionals in this room, 9 times out of 10, don't make yourselves the owner of the controller or the cell account. Make the end user the owner. Even if they don't even know how the thing works, set it up on their Hunter SSO account, then make yourself a crew member in the software so you have access. You're basically looking over their shoulder. This can become very important down the road. If you're doing maintenance on contract and that maintenance is up in a year, maybe it's going to go to a different contractor. Make the end user the owner, because then it always stays with him and he gets to pick which contractor does what. This is the new thing I was telling you about, the A2C LEM. This is how they come in the box. This is a cell module with a SIM card in it. This is your little antenna. The key with cell, you've got to get that antenna outside in the open air. If it's inside a pump station or in a utility room or in somebody's bomb shelter, which one of them actually is, you ain't going to get no cell coverage in there. The thing, we make an extension kit. You can go up the wall or out and then outside, but it goes 9 feet. 9 feet is a spec max. If you go further than that, then it starts eating up all the signal that you gained by getting the thing outside, right? You can't just run the thing forever. If that antenna is inside a metal box or a metal building, you're going to have a hard time. This new modem can also work with Verizon. Hunter has never had a cell modem that worked with Verizon before. Verizon is a big carrier in the United States, and a lot of times they'll cover fringe areas where AT&T will not. I'm sure that works both ways. And these were the 2 technologies that are built in. This will also make a difference in Deutschland, because in the US of A, we're kind of standardized now on Cat-M1, which is faster for Internet of Things, for devices. That's not true in the whole world, and a lot of them use narrowband Internet of Things, NB-IoT. So we'll work on either one of them, just so you know. We get asked all the time about 5G. We're kind of waiting for the modem carriers to add all that kind of stuff. But if this has all the frequencies for 5G, and if it latches onto a 5G tower, it's going to use these things to talk. Well, technically, it is 5G compatible.